Find dy dx given that y equals the integral from -2 to x plus 2 of 3 over ln of x dx. All right, now let's take a little bit more closely what's going on. Right? We want to find the derivative of an integral. Right? So at this point, you're probably thinking, well, wait a minute. Okay, I'm going to integrate this guy, right? So I'm going to find the integral, and then whatever that result is, I'm going to take the derivative of that. So shouldn't I just end up at the same spot? And yes, technically that is true, right? But in this case, we're evaluating it at these limits, right? So if you think about this a little bit more carefully, right? Look at the upper limit, right? It's a number. It's a function in terms of x. The lower limit is a number. So we know that once we evaluate it at -2, right? It's just going to be a number. And the derivative of a number is just 0. Okay? So that's really important. The lower limit just has to be a number. It doesn't matter what number it is. Right? The upper limit should be x or a function in terms of x. So in this case, right, the formula says, right, that d dx, right, of some integral, and I'm just going to use the variable t, right, and the answer should just be f of x, right, which means I'm going to plug in the upper limit, or x, into the function, and that's it. That should be my answer, right? Hopefully that makes sense. So we don't actually have to physically or actually take the integral, evaluate it here, right, and then take the derivative of that. Okay. Essentially what we're saying is, well, everything should sort of just even out eventually. Okay. The problem here is it's not just x, it's x plus 2, which in this case is fine. Okay, because by the chain rule, right, the derivative of x plus 2 is just 1. So in this case, what's our final answer going to be? Right, it's going to be 3 over the ln of x plus 2, right? So I'm going to plug in the x plus 2 in here. But notice the derivative of x plus 2 is just 1, right? So in that case, we don't need to worry about that. So this should be the final answer.